To find the displacement delta x, when the initial position was not x equals 0, we divided the area under the VT graph, or under this curve here, into a rectangle and a triangle. Can we now express that as an equation that will also work to find the displacement? Last time, when we had the zero acceleration, we started with the equation and showed how the graph would work, so we're going backwards this time, going in the other direction. Well, of course we can, or we wouldn't have asked the question. So now, let's look at the area of the triangle. Okay, that's half height times width, but now let's put that into letter form. Well, the 1/2 stays, but what's the height? The height, as we actually did, is the VF over here minus the initial velocity over here. So it's VF minus VI, and what did we multiply it by? The elapsed time. Okay, so now how about the rectangle? That's a little simpler. It's the initial velocity here, 2, times the width. Once again, the width is the same value of time. So we have this, and we have this. We now add those two shapes, and the total area under the graph is VIT plus 1/2 VF minus VIT. And what does that equal? Well, that equals the displacement. So the displacement is right here, 1/2 VIT plus 1/2 parentheses VF minus VIT. We rearranged that a little bit, and what did we do? Let's see, we have a VIT here, and we have a minus half VIT, right? The half multiplies it. You subtract that, and you get just half VI. And then, of course, VF here is all by itself, also multiplied by a half. So just to review, VIT minus 1/2 VIT is a positive VIT over 2. I know we skipped a few steps here coming up with this, but see if you can, why don't you just write it down on a piece of paper and make sure you can get there. But we now have the displacement is 1/2 parentheses V initial plus V final, close parentheses, times time. We'll now do a few problems using this formula right here to find delta x. Be sure to follow the problem-solving template that we've provided. And we can also write this as what? What's half of initial plus final? Well, that's just going to be V average. So delta x is also equal to V average times t.